The real problem here is that now we've got a tool that is good, but it also doesn't necessarily fit how games are actually built.
Welcome to a new episode of XR and AI Spotlight, the show where we give the stage to the founders and makers who are pushing the boundaries of XR and AI. My name is Gabriele Romagnoli, I'm your host, and I'm here today with Tommy Thompson. Tommy works as a consultant in artificial intelligence with a primary focus on the video game industry. He is the mind behind AI and Games, a YouTube channel with over 200,000 subscribers dedicated to increasing awareness of AI research and development within games. As a result of his academic and professional experience, he took on the role of advisor during the GDC AI Summit. Listen to this episode because you will learn how AI is still finding its way into game development pipelines.
Stable Diffusion has existed for less time than it took Square Enix to make the most recent Final Fantasy game that came out 2 months ago.
The cautious approach that big game studios are taking to Gen AI.
Generative AI for a lot of game studios is incredibly risky at the moment, given the protection of intellectual property assets, the ownership and copyright issues, the legal regulatory frameworks that are now rolling out, and also just the inherent cost of it.
How a small game studio can capitalize on this opportunity.
So I think there's greater opportunity for them to actually drive a lot of the conversation around the applicability of generative AI for specific gameplay opportunities, just because they're more willing to experiment and take on that risk, and also they're probably going to build their games faster as well.
And his expert opinion on how Gen AI will evolve over the next 3 years.
A lot of AI companies that have emerged in the last 2 years are going to go bust. But equally, we're going to start seeing more and more.
But before we get into it, I wanted to thank our sponsor Meshy, who made this episode possible. Meshy is the real powerhouse for generating 3D assets with AI. You can start with a simple text or image prompt and get high quality stylized model in just a minute. One feature that I personally love is the ability to create stylized textures for any mesh with or without UV, and since the release of Meshing 2.5, pro users can even edit only section of the generated textures with just a text prompt. Try it out, go to meshy.ai, start the 7 days trial, and after that, use the code XRAI20 to get 20% off your subscription. And now it's time to roll the title and welcome Tommy under the spotlight. Hi, Tommy.
Hey, thanks for having me.
I started following your channel and I was truly impressed, and I really appreciated the way you tackled this topic in a moment where there is a lot of hype and it seems people are trying to grab their attention of the audience with big thumbnails or clickbait. I think your approach is really, really great. And I started following your channel. So one thing that I started understanding is that there are actually many different ways in which AI can be implemented in games. You mentioned about various AI techniques from symbolic AI to machine learning. So maybe why don't you start unpacking this for us?
Yeah, sure. So I think it's important to understand that AI has been in the video games industry pretty much almost since its inception, really. If you go back even to the very early days of sort of the 70s, where you even had enemy opponents that had to be programmed in some capacity. Now, sure, a lot of that wasn't particularly intelligent, but it was always with the intent to have some sort of interesting, rational, autonomous behavior happening as part of your gameplay experience. And so really still to this day, when you talk to the majority of people who work in the video games industry about AI for games, what we're talking about is player-facing experiences. And so that's usually having AI that will act as an opponent, for example, in a strategy game, or we're creating a non-player character that will exist within the confines of the game. We think about characters like Alex from Half-Life 2 was probably one of the most high profile for many years. This idea of a character who followed around with you and participated in the experience alongside you. And then in the kind of 90s through 2000s, there was a big swell of particularly symbolic AI methods that we collectively still to this day call game AI. And it's really specific AI implementations or techniques that solve specific game design problems. And this is largely popularized, for many years, it was popularized by first person shooters. So games like Doom, Quake, Half-Life, Halo, Fear were very pivotal in the development of AI for games because that was the big genre at the time. And so subsequently, a lot of investment was put into making interesting things to shoot at, I think is probably the most succinct description I can come up with. And then we've sort of moved on a little bit in the last 10 to 15 years. I often refer to it as a silent revolution because deep learning came along. And one of the things that, funnily enough, I think, you hear an awful lot about deep learning, courtesy of Google DeepMind's work, where they had like bots, like they had AI that they trained to play a variety of Atari games, for example. And then there was the AlphaStar, which was the bot that could play StarCraft 2 at a Grandmaster level. Those are really cool, but they're actually not very reflective of how deep learning could be used in games because they're not really solving a game design problem. But interestingly, one of the things you see nowadays, and I have a full breakdown on this on my own, on AIandgames.com, on my own website, where I also show how AI is now used in production an awful lot. So if we want to speed up the processing of animations, or the selection of animations rather, cheat detection, toxicity, even things like visual upscaling, which happens a lot in games. Anyone who owns an NVIDIA GPU, for example, has probably been running a DLSS setting in many of their games. That's an AI tool that is being used to facilitate an aspect of production and also improve the overall quality of the game. And so we're in this space now where AI gets used largely for gameplay and it's also now being used in production, but the particular types of AI we're using in these spaces differs drastically from one another for the most part.
Exactly. And one thing that also was very clear and helped me to understand from your videos again was this meaning of symbolic AI, when AI trying to find a new stage, a new solution to a problem that, if I have understood correctly, if the character of a shooter hides behind a wall, what are the opponents gonna do to react to that? So trying to find a new state to a solution that was triggered by the user. So this is what an example of symbolic AI, correct?
I mean, certainly, probably the algorithm it'll be a pathfinding algorithm of some sort or other utility-based calculations. But I think critically, one of the interesting things, and this is why we tend to talk about game AI specifically, is that depending on the problem, whether the solution is optimal is actually an open question. So maybe we want a character to go from A to B. Okay, we might want the optimal path because in the context of the moment in gameplay, well, the player really wants this character to be following us as efficiently as possible. Coming back to the example of a combat sequence where there's a lot of suppressing fire, grenades, or whatever, if you're playing a shooter, for example, that's a very different conversation because now we want something that is interesting. Because if those enemies were playing optimally, they would probably find a very good coordinated strategy and wipe the player out. And then that's not interesting or fun for us to experience. So what we want instead is for them to find areas of opportunity that, from the player's perspective, when they will see that happening, they'll think, oh, that's cool because it's challenging me in an interesting way. But also subsequently, it might be exposing those characters in just the right way to give the player what they needed in that moment, that then they can like maybe eliminate one character, one opponent, and then that's going to change the tide of the conflict, as it were. So it's always about making interesting decisions in the context of play.
So we are gonna certainly also do a transition into that, let's say, deep learning, as you mentioned. I want to stay a little bit on this topic of symbolic AI and the importance for the gameplay. So how do you actually, let's say, fine tune the AI in a way that it stays interesting and challenges the player and just doesn't try to find the most optimal solution? So how do you design with AI in mind?
So critically, and I think this is one of the big reasons why machine learning and deep learning specifically have not been used as pervasively in this space, is because there's a lot of minute control that designers like to have available to them. And critically, it will happen on a moment-to-moment basis, where it could very well be so say you're using a particular methodology, maybe a planning technique or behavior trees, for example, or finite state machines. Now, these are all conceptually very simple compared to a lot of contemporary AI, but one of the reasons that they're so effective in games is that they allow for tremendous amount of parameterization. that can be adjusted and adapted on a moment-to-moment basis, not just from level to level, but encounter to encounter on a level, or even in real time as the player is participating in the experience. So it could be that the player is actually being very aggressive. And so in turn, we might change certain parameters to make the enemy characters more aggressive, or they're a little bit more capable of keeping up or keeping a pace with how the player is performing in the moment. Also, there's a lot of we talk about it a lot in video games. We call it smoke and mirrors. The idea that really a bulk of what we really see as intelligent gameplay is that games will cheat or cut corners in specific cases that, sure, it removes the purity of the intelligence of the system, but in the moment to moment, the player had a good experience and we go, okay, cool, that's fine. So it could be that you actually have a large selection of behaviors that have been designed by a player, a game developer rather, and they know how they'll work in certain contexts. And then we say, okay, well, we're going to enable or disable certain behaviors for this part of the game. And then maybe later we re-enable them, or we enable them at key points, because you also want the player to gradually learn how to play the game as they're going. And if the enemy, for example, has all of its faculties at the very beginning of the game, then that's not going to be as fun. So maybe they don't use certain strategies, they have poorer accuracy, they're slower to react to the player. But as the longer you go through the game, all those numbers begin to get adjusted slightly. Until to the point where you could be fighting the same template of character in the 10th hour of the game that plays quite differently from what it did in the opening 20 minutes, because all these different parameters in the back end is being adjusted to just help it keep a pace with the player's overall skill level, and thus ensuring that they're continuing to have a fun experience and not getting bored the longer they play.
And this kind of like reminds me a little bit, and sorry for the analogy, but I've been playing Dungeons and Dragons for quite a long time, being like
Right.
the dungeon master, and there are rules, right, written on a book that you follow most of the time. But then it happens that sometimes you want to cheat as a game creator, as a storyteller, just to get the experience better. And it doesn't matter
Yeah.
if you're breaking the rules, because at the point you're doing it for the sake of the experience. No, this one shouldn't die at this moment, or this door shouldn't open for whatever other reason. So it kind of like reminded me a little bit of this example where you are there to provide a great experience, not necessarily to follow a bunch of rules.
Yeah, and it isn't universal. I think actually there's an interesting issue there to unpack, because as a DM, you'll know what you think was the right call to make, when to break from those rules. And there's an interesting relationship between a video game and its player, that sometimes people feel cheated when they realize that the game is cheating on them. And, particularly strategy games in the 90s were notorious for cheating and having information that the player didn't have at that time, because it was otherwise it was very difficult for the AI to know how to plan and strategize at that point, because we didn't have the technological affordances really to try and tackle some of these problems. So, and then other times a character will cheat and you go, you know what, that's fine. Like one of my most popular videos I made, it was a few years ago now, is I had a look at the AI, the companion characters in Tom Clancy's Ghost Recon Wildlands. And you have a team of, when you can play this online with friends, but also you can play it with a couple of bots that are like your squad and they follow you around. And I gave this breakdown of how the squad cheats all the time. They do all these things that they shouldn't be able to do. They have all these abilities that they can't really have. Like they're able to make shots that are impossible for the player to make. They sometimes become invisible when the enemy can't see them. But it all facilitates that experience. And it was really interesting when I make a video like that and I see the response from the audience, who say, "Oh wow, that's really cool." Like either they'd spotted that and they weren't sure, or they're like, "Oh, that's cool that even they just thought to make them cheat like that." And I remember there was a really good, it's based on a talk that I saw many years ago by one of the developers at Ubisoft Montpellier. I sadly don't recall the name of the gentleman who provided the talk. But the big reason for it is they said it would be so much harder to make this game play the way we wanted to by making the AI behave realistically. So instead, if we just cheat in all these key areas, then it actually makes our job a lot easier, even though it still took them several years to put it all together into the finished game.
So it's very fascinating because I think it gives a different views, let's say from a non-developers perspective, from the people that are behind the screen, let's say playing the games of what are the nuances and choices that things that have to be made. I wanted to move a bit the conversation, and so you have seen a lot over the last decade of how AI got into got implemented into games, right?
Yeah.
In many different ways, right? From indeed the symbolic AI, from machine learning based AI. So, is there something that over the years you didn't expect to happen?
I think coming back to this notion of this silent revolution in deep learning, that was something that took me by surprise. So, and I think part of that is also due to my own background. So, for context, I have my PhD in AI is actually split between symbolic AI and machine learning. So I actually I have quite an extensive background in machine learning. And one of the interesting things we were trying to unpack, and so to give context, this would have been, I passed my PhD in 2010, right? So a couple of years before deep learning was really a thing. At that point, we were looking at machine learning to try and solve game design problems. And we're going, this doesn't work. It's just not practical. It's not scalable. And critically also, I think when you wind the clock back 15 plus years, the tools weren't there. If you think about how machine learning has exploded in the last decade or so, it's because the tools are so much better and they're democratized in a way that, I sometimes think about how much faster, if I went back and revisited my PhD today, I could probably do it in about 6 months because I
So,
used to have to write all my ML libraries, for example. And so it's like, oh,
uh,
that's
when you
drastic.
mention tool, what you exactly are referring to, just so that we.
Yeah. So if we think about access to like TensorFlow and PyTorch, like software libraries that allow you to just implement a neural network, train a neural network against a set of data, being able to pass in data, clean it up very quickly, and then get it ready for processing and running it.
Mhm.
That is already a huge difference. I used to have to write all my own libraries back in those days, and they weren't very good. They were terrible. Student programmer trying to develop his own AI. And so when you see that conversation that we were having about how we could maybe use machine learning, and then data analytics was actually probably the one thing we predicted because we started doing that like almost 20 years ago. We're like, hey, look, here's how you can actually gather data from players and learn interesting things about them. But seeing things like motion matching, which is training animation blends. So if you're not familiar with the minutia of animation in games, if you have a character that is standing still, walking, running, maybe they're crouching as well, and then walking and then like crawling around or crouched crawl, whatever. Those are all separate animations built by an animator. And then you have to figure out how to transition from one into the other. At what point does the walk become a jog and a jog become a run, for example? Traditionally, for a game developer, a technical animator has to sit and figure out the point where you transition from one to the other. And they're called blend points. This is a very time consuming process, and it's also incredibly difficult the more complex and realistic the animations are, particularly when you also factor in if it's kinematic and it's respecting the movement of the body and the physical force being applied to it. So you could get a human to do that, but actually training an AI to figure out these like good points to blend between them is a really, really interesting application because it's a tool that solves a problem probably at a higher level of fidelity than a human could, and it will also do it often much faster than a human does. And so for the animators in the game, like in the in the project, they're thinking, good, we get to focus on building really good animations. And sure, this is still going to take time. It's like it's not a perfect system. It doesn't just magically put it all together, but it's much more smooth. And as a result, it will mean that the animators just get to focus on making the animations look as cool as possible. And then, cool, we're not going to lose as much development time trying to figure out all these blend issues, because sometimes the blend issues are so bad, you have to go back to the animator and say, I need you to redo that animation to fix this particular problem we're having. And so that's just one indication of like, we used it to solve a very specific problem. And I think for myself at that point in time, I think critically the reason that I wasn't aware of that was because I came from an academic background. I used to work as a university researcher and lecturer. I didn't have that expertise of knowing what those challenges are at big game studios. That then once That was it. It was once that knowledge and those tools were more readily available for those game developers, they were able to say, hey, we've got a problem that might actually fit this. And so, yeah, partially it was just due to a lack of understanding of what the challenges are at that level of development.
Yeah, and that disconnection between academia, let's say, and the game studio. It
Yes.
sounds like.
Which it's much. I think the communication between those two is much stronger now than it's ever been. But I distinctly remember, yeah, going back 20 years ago, we would be having conversations about this where academia is thinking, oh, we'll solve this problem, and game developers are going, no, like solve this problem. This is the problem we actually need solved. And yeah, they were just going to talk over each other. But things have improved drastically, I think, since then.
So far we discussed examples around this way in which AI can be implemented for the gameplay, let's say, or to facilitate the work of developers in a sense. But then there is a big hype around what is, for example, Gen AI for 3D assets or motions or sounds and so on. And also there is this also other line of hype where we see people and companies like, I mean, I wouldn't even say hype, I wouldn't even say hype, but places like companies like Inward, they are positioning solutions that allow indeed to speak to NPC characters, let's say, that have let's say AI embedded in them, like for example, ChatGPT and so on. Everything looks promising, but at the same time, there is a lot of hype around it. Can you maybe how can we look through this hype? Is there anything solid behind it?
Yeah, so I think it's important. I think actually coming back to what I was just saying about the deep learning innovation that happened, when, like I say, the conversation around deep learning for games was really driven by the work that DeepMind were doing. So we saw the Atari players, we saw even things like AlphaGo being able to play Go at this really high level of competence, and then also AlphaStar with StarCraft. And as I said earlier, these are actually they're not very good examples that are reflective of how it could be used in games, because they're also not reflective of how games operate or how games are made. And I feel like we're kind of in the same situation with this right now, because you look at a lot of generative AI and go, okay, this is promising. And I think critically, a lot of it isn't quite there yet. And I see this in a lot of different sectors when we've got model generators, text generators, art generators. It's like, okay, we've got the first bit down. But the real problem here is that now we've got a tool that is good, maybe not great, but it also doesn't necessarily fit how games are actually built. And so subsequently, it's kind of like putting the square peg in a round hole, where you're trying to, okay, we think we can make this work in this context. And so, I mean, I'll give an example. I do a lot of consultancy for games companies, and I've done a few recently where I hang out at the studio for a week, and one of the things I get asked a lot is, could we use GPT to do this part of production? And I say, yeah, we could probably figure out a way to do that. And a lot of that is just really just teaching prompt engineering or showing an interesting way that we can interface with like a GPT, the GPT API, for example, to hook an existing piece of code that the tech team builds to help facilitate a design need, for example. And so it feels like right now we've got a lot of really cool stuff. It's not, a lot of it isn't quite there. And I think critically, the other thing to really preface this with, and I talk about this a lot, is that generative AI for a lot of game studios is incredibly risky at the moment, given the protection of intellectual property assets, the ownership and copyright issues, the legal regulatory frameworks that are now rolling out, and also just the inherent cost of it. A lot of the time, companies are looking at big third-party tools and saying, oh, that is giving off too much risk, too many bad vibes. And to the point, they actually start developing their own versions of it internally, because they're also just not convinced and they want to play with it themselves. I think for every AAA company, so the really big studios like Activision and EA and Microsoft, Sony, all these kind of companies of this magnitude, I know they all have their own internal large language models. I know they have their own internal image generators. They're all building their own versions of it because they're excited about it, but they're also not convinced yet that it's actually applicable. And thinking about the deep learning example from earlier, a lot of those companies have had AI R&D teams for a long time now, because that was how the deep learning innovations came about. They toyed with deep learning internally and then finally went, hey, this actually could work. Now let's put it into a game and then see whether it works in this one game. And then if it continues to work well there, it will begin to permeate either within that company's provision of titles, or they'll share that knowledge at somewhere like GDC, and then the rest of the industry begins to also adopt it. So I think we're still at that early ideation phase, and you can tell because there's not that many games at that level that are actually using generative AI at this point in time.
But then would you say that the innovation then is going to come from these companies that are building them internally? Because if one of the things you mentioned as an obstacle is that there are these technology that are trying to fit into a workflow that doesn't that is already established, right? And changing
Yeah.
workflow is always super challenging. I just wanted to have a quick break to remind you that the recording of these episodes and many more great conversation with incredible experts are available on YouTube, Spotify, or Apple Podcast. Just head over to my profile or in the episode description below and pick the platform you prefer. And now let's get back to the show. So
Yeah.
we're talking about instead about a place where AI or these Gen AI solutions are going to be made by Ubisoft, EA, or Sony, and then into their own games, and everything's going to stay in-house in that case for these big studios until they figure it out. Is that the way you see that evolving?
So what I've observed over the years is that they're actually quite happy to share knowledge. That a lot of the R&D teams out there are happy to actually, they turn up at academic research events. They go to things like SIGGRAPH as well as going to like GDC, and they give talks to give context. So, like as you said, I'm on the advisory board for the AI Summit at GDC. We had Google come by and present some stuff for us. Unity, sorry, not Google. No, we did have Google. We had Google, we had Unity, we had Ubisoft all come out and present stuff that they're working on right now that is still experimental. It's still not ready yet. And also these people all talk to each other. And so it's nice to see that they are exploring this together and often sharing ideas. I think, coming to your point, I think one of the problems that then emerges is that the application of it is often then exclusively to companies that have that level of internal expertise and resource that allow them to apply it. And then the problem then becomes, well, for a lot of smaller studios, even like small independent teams that are maybe a handful of people, if not one person, where do they get access to that technology? They might have to rely on an engine provider like Unity or Unreal even, to be able to say, hey, we're now providing a particular feature in our engine that allows you to utilize some form of AI in a particular way. And so, yeah, there's a lot of internal conversations, but how much of that actually feeds out to different parts of the industry, that is an ongoing challenge, I think.
You brought up in the game studio, small game studio, and that would be actually one of my follow-up questions. So you mentioned that big companies are a bit careful about implementation due to the regulations and so on. That being one reason, would they fit in their workflow? How do you see instead the smaller studio adopting this and reacting?
So I think there's a couple of factors here. First of all, I would imagine we're going to start seeing, and we already are actually seeing, a lot of smaller companies taking more risks with this technology and trying to apply it. One, because I think there's a couple of reasons for that. One, that sometimes I don't think they're actually aware of the issues that they face in front of them, and then that might become a problem for them down the line when they try to release and sell the game. And also, when regulatory frameworks begin to change, is my game still legal? So that's one thing. But I think critically also that indie games tend to be built faster. By and large, I think one of the things to really put into context, I gave a talk in London last week, and one of the things I pointed out was that Stable Diffusion has existed for less time than it took Square Enix to make the most recent Final Fantasy game that came out 2 months ago. So Final Fantasy VII Rebirth had a 5 and a bit year development life cycle. How long Stable Diffusion been around? It's not been that long. And so that is very indicative of why you don't see it rolling out as pervasively. And actually, the handful of games I can think of that have put generative AI in them, like the commentators in the finals, that's voice work is all generative AI. Or Foam Stars has little generative bits of art as a collectible item you can unlock in the game. These are relatively spurious, and they could remove them very quickly if legal landscapes or what have you change very drastically. But a big AAA game will take conservatively, like a fast AAA game is 3 years. More recently, probably one of the biggest selling games of 2024 is Helldivers 2. That took 8 years for them to make. And so you think, hang on, so somewhere 3, 4, how long has it been since Grand Theft Auto, the last Grand Theft Auto? Rockstar have been working on that for a very long time. When those games are in development, they're trying to make their judgment on what tools they can apply, the risk that that tool will then have, the viability of it over the production pipeline, because that also is then influenced by the platforms you're going to sell it on. These decisions are often made very early in like the first quarter of production. And so you make that decision then and you largely keep to it. So then it's like, oh, well, they're looking at these tools now and going, oh, we're still not convinced yet. And so, okay, right, well, our game that's coming out in 2027, 2028, we're not going to use generative AI for it. Maybe the next one. But an indie who's looking at something now is able to put it into their game and they're like, well, we've got to launch in like 12 months because we run out of money. Or, you know, it's somebody doing it in their bedroom in their spare time. So I think there's greater opportunity for them to actually drive a lot of the conversation around the applicability of generative AI for specific gameplay opportunities, just because they're more willing to experiment and take on that risk. And also they're probably going to build their games faster as well.
So, and then following up on that, some of the audience here at XR Spotlight are also indeed small studio creating XR games. And it could range from indeed a bedroom creator to 10, 15, 50, 100, right? So it's still like an average small size studio. Based on your experience, what are, maybe with an eye on XR, maybe, I don't know if that would be something that you see more specific, but in general, some of the things that you would advise or the smaller studio to look into or use as a Gen AI tool or techniques to improve their workflow or increase their output or enable the players to have more interesting mechanics?
Yeah, I think being able to, I think there's a lot of interesting stuff in the context of XR, really around being able to capture and understand in the moment to moment what's actually happening in the game and being able to process that fast enough that you can then react to it in an interesting way. So sort of a predictive player modeling aspect that particularly if you're training things like actually like often using language models as an interesting predictor of how to decide an outcome, I think is interesting. Like coming back to that DM idea of being able to observe the player in situ and how they're quickly processing data about how they're moving around the environment and interacting with their environment, could that then lead to another opportunity? Particularly with XR, because you can be a little bit more experimental with how the world around the player actually reacts to you. If you think about the minutiae of how things like large language models actually work, they're really just statistical probability models. They're really just providing you a statistically likely outcome based on the input set. And so if you can come up with some interesting ways to map that data and then apply it, even if it's just through clever prompt engineering in an LLM like GPT, that's actually quite neat. Even just having dialogue that is evocative or reflective of what is happening in the moment, or even what is in front of you, for example, using image recognition, deep learning models to allow you to actually begin to determine, oh, that's a water bottle and that's a mug full of coffee. And then having characters actually able to react to those objects that exist in your world. Like that's incredibly cool, because also you don't have to sit in, ideally you're going to find a lot of, and I think this is a critical point to make, a lot of these kind of problems, there are existing, you can go out and Google for them, like freely available models that are pre-trained that solve some of these issues. I think Intel was doing some really cool stuff with this, with their Vino libraries a while ago. I remember playing around with those. But just the ability to say, oh, right, there's actually a pre-built model that's able to do basic image recognition on like objects expected to be found in your house. And then it can go, oh, hey, that's a coffee cup, that's whatever. And then have characters able to react to that and process that information. Like, that's very exciting to me, because you're allowing more customization of the experience relative to the player, rather than simply just mapping the existing game experience into the local confines or the environment that the player has. It becomes more of a dialogue or a conversation between the player and the game, rather than simply the game giving you this one option.
And I mean, I think that was a great example from the XR side, right? So thanks for sharing. And what about maybe, and again, if nothing comes to mind, it's totally fine. But I was thinking like something that could enable small game studios that not necessarily XR related in terms of tools or techniques that could benefit them.
I think certainly, like, there's even like really cool stuff that you can do. You can actually use a large language model to act as a behavioral system. So if you give it the parameters of how you expect characters to behave, or like you define certain rules of how it behaves and then use prompt engineering to dictate the output format of it, you can actually get it to generate the actions of the world for you, or find new ways for objects to be generated in your game. So could you actually have an existing, text to model generator that allows it to generate particular objects in the game, and then have that become a mechanic where players can create objects on the fly, and then hopefully, if you recognize the type of object or what type of properties that object might have, you could then give it gameplay functionality. Thinking of like Scribblenauts, for example, from a few years ago, where you could type all these different things in that would generate all these objects in the world, but those were all pre-built. What if you could at least begin to say, well, this is a projectile, for example, and then have it that it can generate that projectile for you as a simple model, and then you can actually apply that and it give it gameplay features, I think, as well. That's kind of a crazy little idea, which that's a hard one to scale, I think. But like the capacity to build something like that now, I think is far more attainable than it would have been even 5 years ago, frankly.
You brought up this topic about indeed text to 3D, or there are different ways to generate 3D models. And when I was thinking about our conversation, I, of course, ideas and about games that rely as user-generated content as one of the main driver, right? These
Yeah.
games where you can build world. We're talking about Roblox and many more. Now, I haven't seen any game yet that is implementing something like this. You mentioned it's a problem of scalability. I imagine being a problem of cost. But how
That too.
long do you think it's gonna take to get those Gen AI as, let's say, a gameplay element within a game for 3D assets or maybe for other forms of content?
So I think if you've got it tightly scaled or tightly confined and regulated internally within your, like, you've defined it like, okay, all the things you can build are actually relative to a model that you've already got. You know what the model can create. And I think that's a critical part, is you know what the model can create. That makes it far more plausible. The other, I think, in terms of the scalability, that's one thing. So if you can able to constrain it to a certain domain reflective of the type of game that you're making, or the aesthetic or tone or environment that the game exists in, the story that the story world that the game exists in, that helps. The other thing is actually, and was kind of the one thing I was missing a second ago, is that it can be trusted in what it generates. And I think that's a big part of why you don't see it as pervasively yet. So if you were to have a model that's able to generate certain assets, how do we know that it doesn't generate undesirable assets? Now, that's something that is very, very difficult to determine. And again, this is a risky element, which the developer themselves might not be concerned about that. But then you have to think beyond your own development team. So, I want to make my game and I want to publish it on Steam, for example, on PC. Well, Valve now have guidelines on this. And you have to be able to prove that if you've got a model that is generating live content in the middle of the game, that it's not going to generate something that is insensitive or critically is going to violate your age rating. And if that happens, they might pull it down. Also, one of the things that Valve is doing, they're actually rolling out an update to Steam. I don't think they've done it yet. I think I would have noticed. But in the event you have a game that has these kind of properties, a player will be able to live report the asset that is generated. Like it'll do a screen grab and send it to Valve and go, this game is actually violating your terms and conditions because it's generated something. And that could be something that is highly undesirable because it has, I don't know, sexist,
Easily,
racist,
so many.
fascist connotations, but also it could be, it's like, oh, I've made my little platform game and it's generating assets that look like they come out of Super Mario or Sonic the Hedgehog, and now that's IP infringement. And so it's a whole mishmash. So it really comes down to being able to know where your data is coming from, and that you trust the data that, or the model that's been trained, that you're like, I know that this thing isn't going to generate anything that is going to be a problem in the context of our game. And again, this comes back to this risk proposition. And I think that's why we're not seeing it as pervasively yet, because we still need to figure out the ways to ensure that it can be a trustworthy asset within the context of the production.
So I have one last question following up on that. But before, actually, there was another thing that came to mind. And that is the kind of team that you would need to put together to start leveraging AI. So let's say I'm a small game studios, right? I have a bunch of developers, some designers, some 3D artists. Do I need some figure specific, or maybe would I need to upskill the people that I already have in something specific? Like, what advice would you give to these studios that are looking to explore this actively?
I'll be cheeky and say, come and hire me to consult for you for a bit, and that'll help. But no, I think in truth, it certainly skilling up is a big challenge. Like, one of the things I do is I run professional training at games companies, because you have a lot of people who are very technically gifted and they're very good at this particular skill set, but are perhaps not familiar with how a lot of generative AI tools will intersect with their space, but also whether it's relevant in its current form to what they're doing. But even then, it's one of the things we had a question this year so I attend the AI roundtables that run at GDC, and these are people from across the sector come and sit down. And I like to go to the beginners one, because the experts one is everyone just moaning about the same 5 things we haven't managed to fix in game development. And it's like, okay, cool, we're not going to solve that in the next 45 minutes. But I really enjoy the beginners roundtable. And one of the questions that was raised is, if I'm interested in building AI for games, do I need to know anything about deep learning? And the conversation, like, it was interesting who you spoke to, what the response was, because some people said, no, you don't need to know any of this. If you're creating characters in games, making opponents in games, just learn the traditional stuff, the game AI stuff. And then other people kind of arguing. I'm in the middle. I said, look, some of this is not immediately apparent or relevant yet to what you're doing in your part of development, but it's also very good to be at least base fluent in a lot of the core technologies, because critically it's able to understand how these things change. So as a programmer, being able to just learn the basics of how deep learning and machine learning more broadly works. And the reason I just say the basics, because a lot of this technology is changing very quickly, but at the same time, it all comes from the same conceptual basis. Because generative AI is a subset of deep learning. Deep learning is a subset of machine learning, and machine learning is a subset of AI. That once you understand the theoretical underpinnings of it, you begin to understand how each of these subdisciplines operate. Oh, deep learning is actually machine learning, but specifically, mostly with we've got feature extraction, convolutional, deep learning, deep networks, and then different types of deep networks, and then that leads to generative AI. And it's like, so understanding that, I think, is useful. But also, even if you can look at how potentially these technologies could impact you in a more desirable way in the next couple of years. So I think generative art, for example, rightfully a lot of artists are concerned about that, because they think, oh, right, this feels like it's trying to take my job. I think being able to see the potential of how this could be used in a more practical way a couple of years from now, because I think in reality, a lot of the tech that is effectively advertising to take their job, we're not going to be using it, because we've already, in fact, a lot of studios have already done that internal research and went, this isn't practical for what we need, but we really need this tool to just help elevate that artist's ability in a specific way, or help them in a very particular way. And I think, so at least being a little bit more familiar with the state of this technology and where it's going, I think can be very useful, just collectively. Because that is also, I mean, like I said, I do work for studios, but it's also quite often the number one thing is I sit down with a team of people and they go, none of this makes sense to us, and we don't really understand what any of this is, or even whether it's relevant,
You are saying something that makes a lot of sense. So it's like, oh, should I hire someone? Should I not hire someone? Or what? Maybe the point, okay, let's take a step back. And when we're talking about AI, what are we talking about? What is our
Yeah.
need at the studio?
I mean, to give a specific example, one of the studios I went to a couple of months ago, I was, depending on who I spoke to in the company, we were talking about different types of AI. So in art and animation, we were talking generative AI, but with the tech team, we were talking game AI and a little bit of deep learning. And I think it's even just being, as you said, like, do we hire someone in? It's like, well, do you even know who or what skill set they have that you need to hire in? So at least getting a bit more of a grounding on the overall sector, such that you say, okay, maybe we do need to hire someone with this specific skill set come into the team. That's useful to even just get that base grounding, really.
Yeah, yeah. So you mentioned that right now the general vibe is that there are, let's say, a lot of risk, and people are kind of
Mhm.
like waiting and looking at it. What is your prediction with how this is going to evolve in the next year to 5 years?
So I'll start with the not so nice bit. A lot of AI companies that have emerged in the last 2 years are going to go bust. Because a lot of companies have received a large amount of funding to be the first in the room and to show, hey, we can do this. And it's like, okay, these are cool, but right now it's not really applicable in a way that we want. Whether it's because it doesn't fit a production need, it doesn't solve a problem that actually needs solved the way that it's being proposed, or even just it's too expensive in its current form. So, even with generative tools are often quite expensive because they have inherent cost because they run on a web API. They're all being deployed on Amazon Web Services or something like that. Like Stability, for example, is hemorrhaging money right now because of how much it costs them to keep all their services online. So right now, I think a lot of these are going to die off. But equally, we're going to start seeing more and more survive and persist because they begin to solve very specific problems that, from a game development perspective, people are looking at it and going, hey, that is less risky, it's more cost effective, and it actually is solving it's either solving a way something we already know is a problem in a way that could be useful for us, or in a way that we hadn't anticipated and we want to try it. And I've already seeing those new companies emerge. A lot of them are in stealth mode right now, where they're like, but this is the thing we're working on, and they tell me what they're working on, and I go, oh, you're solving this problem that these 5 other companies couldn't figure out. And interestingly, a lot of them have game developers on, or co-founded by game developers who have seen the space and went, right, I need to learn more about this because I've got 20 years experience in the industry, and I can then figure out how this can be applied in the context that we need it. So I think that's one big thing, is that the companies that exist is going to change, either because of financial problems or also critically because things like the EU AI Act is going to kick in over the next 12 to 24 months. That's going to have a huge impact on the sector. Then the next thing is we're going to start seeing what really the industry is looking for is tools that solve very specific problems and are more accessible to people who don't have backgrounds in AI. That it's like, okay, cool, this is solving a very particular need. And we can start applying that because a lot of those tools already exist. People think about game engines like Unity and Unreal, for example, but there's a huge number of middleware companies out there that sell very specific products that solve very specific problems in a game production pipeline. And a lot of them have been around for 10, 20 years, at 30 years even at this point, because they're very good at being that one thing that solves that one problem. We're going to start seeing more of those crop up that are powered by generative AI. And I think that's quite exciting because then we're going to actually start getting into how we can really start utilizing a lot of generative AI in ways that are far more conducive to what game developers actually need. The last thing, indies are going to start shipping games with generative AI in them that is doing weird and wacky stuff. And sure, they're going to have all the legal, ethical challenges that come with that, but also they're going to start driving the conversation on interesting ways that it can be used. Because the handful of examples that we often see, in fact, you referenced In-World, for example, already, is the In-World tech is interesting, but it's applying an AI technology to an existing kind of concept within games. let's start doing weird stuff that we couldn't have even done 5 years ago without generative AI. And I'm not the person that's going to come up with that. I'm not the creative. I'm usually the engineer. But I think it's going to be exciting to see what stuff comes out of that space, certainly. And I think probably it's going to be indies that are going to drive a lot of that.
Tommy, I cannot see a better way of ending this conversation, especially because usually they always end up with a view of doom and destruction in front of us. But I think what you give us instead is it's a very as expected. I was not expecting anything else. Very actionable and very thoughtful point of view. So, Tommy, thank you very much for today's conversation.
Oh, thanks for having me.
It was a real pleasure. Thank you very much for listening in. If you enjoyed the conversation, remember to head to YouTube, Spotify, or Apple Podcasts for more insightful conversation revolving around XR and AI. And if you like the show, please leave a rating on Spotify. It really helps me keep doing this and shine the spotlights on the latest and greatest founders and creative in XR and AI. Till next time.